In this video, I'll go over recalling WAV files. When recalling a WAV file into SoundCheck, the data will always be in full scale. It's important to remember if you saved out a waveform from SoundCheck, it would contain the metadata required to analyze it properly without a stimulus step, and to remember what units it was in based on the calibration used to capture or create the waveform. But a WAV file is always just in full scale. When we're recalling this file, we can choose between two different full-scale definitions. If you choose FS, the peak amplitudes are +1 and -1. There's no possible way to have data that are higher than +1 or -1. To help conceptualize this, think of a fully saturated sine wave. The peaks would be reaching +1 and -1 full scale. That means the RMS value of this would be -3 dB FS RMS, or about 0.707. On the other hand, think of a fully saturated square wave. Those peaks would be reaching +1 and -1, but the RMS value of this would be 0. It would be taking all of the full scale available, and the peaks would be at 1. The other definition for this is FS AES 17. This is according to the AES 17 definition of full scale. This definition states the RMS value of a sine wave equals 0 dB. With this definition, a fully saturated sine wave would have an RMS value of 0 dB FS, but the actual peak on the signal would be around 1.414. The peak isn't defined in this standard, it's based on the RMS, so it is possible to have a greater than 1 digital signal here. A fully saturated square wave would have a +3 dB RMS value according to the AES 17 definition. As long as you choose the same thing, your wave file levels will all relatively be the same. There will be about a 3 dB difference between FS and FS AES 17. Let's look at an example of this inside a SoundCheck. I have a suite which is based on sine waves. This is a 100 mV RMS signal. I saved this data to disk as a WAV file and normalized it to peak. That means I fully saturated the WAV file. Again, it then loses any correlation it had to 100 mV and is just saved as a full-scale WAV file that I could use on any device and program that knows how to play back WAV files. I'll add in a recall WAV file step. Here you can see in this dropdown, I can pick FS or FS AES 17. First, I'll use the FS definition and call it Wave FS. I'll add in a second recall step, point to the exact same WAV file, and use FS AES 17 definition of full scale. I'll change the name on this, and recall them both. Again, this is what I'm comparing it to. I'll add in another display and look at the FS definition first. And here, as expected, the peak of this fully saturated WAV file is +1 and -1. The RMS value of this would be about 0.707 or -3 dB FS. I'll now compare this with the AES 17 definition. I drop this onto the display and look at the y-axis. The units are in full scale, but instead of 1, my peaks are at about 1.414 and -1.414. That would mean our RMS value is around 1, which is dB0 FS, which aligns with the AES 17 definition of full scale. Thanks for watching these videos. There are more helpful resources available online at our website, and if you have any questions, please feel free to call in or email to support@listeninc.com.